I would refer. Yeah. So it's right now, keep in mind that it's probably two important drivers of prepayment. And another driver, of course, it's default models. When people, they would have, in the US, it's called FICO score, some credit score, it would be worse, then they cannot pay, it would be so-called delinquent 30 days and so on. So, so it's a default component, but let's go over. So mortgage portfolio modeling, even mid-sized banks, they could have more mortgage portfolio and some say around 1 million loans. So we will talk a little bit about, I already described, but we'll talk about how it modeling through survival analysis of loans. Then I would describe something, what is called Yefron partial logistic framework. And here what it is important to understand. For finance, if we compare finance and biostatistics, for finance, it's crucial to know that baseline in time, not just coefficients of survival model. Why? Because it's cash flows. We want to know when we get our, if we are the bank, when we can get our money back. So who knows about Cox model? You know that when Cox he published his model, immediately in discussions of Royal Society, when it was discussion about his Cox model, it was presented, I believe it was Breslow, techniques how to estimate baseline. And Professor Kugel, if you feel, please interrupt, because you can give some color to, but it's important. So it's crucially to know. So Yefron in 1979, he published a beautiful paper, and I would talk about it, how we can use discrete logistics with splines for unknown baseline, estimate all together, and have in limit Cox regression. And it's
splines of the first order? Or
what
kind
of? He used cubic splines, and I always would use cubic splines. But here, Professor, it's about your research. Sometimes you don't know where to put your what is the proper word?
Knots.
And knots. Oh, thank you. I forgot in English and in Ukraine. Knots. Because sometimes, and I described when Pani Oksana, she was making her presentation, you have some peaks. Sometimes you cannot process. It's a different story. We can talk about later. But then I would discuss something what is called survival, and sometimes people, they use naive models called scorecard. It's just probability for default. You want to forget about your baseline and say in 1 year, the probability of default 0.7 or whatever. And we have to be skeptical when for one person you would get that probabilistic answer about default. But it's exactly, by the way, what FICA, Professor Mandel, that about that score, right?
A little bit, not.
Yeah. It's just pure as consumer, and it's a different. Now, after that, I would try to introduce the very difficult concept of dynamic covariate. Then I would go over what I did with my teacher in finance. It was his invention. Other banks, they invented it a lot. Again, besides Scandinavian school, I've never seen anything in open literature about it. So then we'll go how to estimate for two-dimensional baseline parameters. I would describe my teacher what he proposes random sampling. I would discuss why it's still problematic and I would talk a little bit about time scaling, and then if we have time, I would go a little bit about philosophy of Monte Carlo and asymptotic statistics. I would, based on Scandinavian school, if I have time, I would show some formula which involve, for me, very difficult things about conditioning, because everything is about conditional expectations. And just for you, in finance, I interviewed from in my life probably around 200 people for quant's position. And I want to say that if people they have mathematical background in the US or quant, it's very rare when they are able to write even classical condition, understand conditional expectation, let's say like in book of Gnedenko. They simply don't understand conditional expectation at all. The only people who understand conditional expectation, it's usually theoretical physicists who would did Monte Carlo. So we'll because if you like, I have also, besides what is in terms of measurements for Cox regression, what I could propose. I know that it could be some new results based on Professor Kukoc and Pani Oksana's research. I could start talking. I have a program, but it's related to filter Kalman, which was supposed somebody talk today. So let's start. It's sorry that I spent a lot of time now outline. Just wanted to give you all that stuff. Okay, so performance of portfolio is function of prepayment rates. If people they move to low rates, where we could be in trouble as bank because we stop receiving from them again. Besides principal pay, that interest pay, and it would be and if they acquire new customers, it will be slower. Just to give you an idea, if you are interested in finance, people would talk in US about treasury market, capital market. The funny thing, the most important market which defines volatility and what's going on the market, it's so-called mortgage servicing rights. Banks often they don't have mortgages, but they have the right to control, like send payment, to accept payments, to give transfer to somebody. So it's market which defines the whole movement often of the whole US market. It's just some amazing. So again, what I already told it, statistical characteristic of the timing of the prepayment event, they are of primary concern of practitioners. Then sensitivity analysis, it's usual stuff. So again, core cuts, often probability of default, or it's just fixed time window for 3 years. You would do some logistic regression, do loan ranking, and use classification and standard, all that what people they like in machine learning and everywhere else, but without dynamics, just classification problem. based on history of borrow. Okay, so now static model is just linear regression. It's but again, here it's something I often I would still use survival analysis even for 3 years, because for me it's better to find probability of default for 3 years. So it's just different philosophy. And here is the whole stuff. What I want you to understand: dynamic risk model. We have baseline of time, and it's some what I called LM in this formula. It's some generalized linear model. So think about Cox. You have that it's semi-parametric. You have baseline, undefined, but it's function, and you have that exponent, and where we are, logistics, semi-parametric. I just told you this thing. Yes, and another stuff, what is important for practitioner. What is the time T? It's time always, because we care a lot about censoring, from origination of the mortgage. So T, it's important to understand, it's age. It's not historic time. A lot of people in survival analysis, they don't understand it, and they do it historic time, and they get in trouble. They cannot describe dynamics. I would explain later. Okay, so here I just explained what we discussed with Professor Kukoc about assumptions about Yefron and assumptions of censoring. It's very important because I mean, if you're interested, I sent, I believe, to Professor Kukoc and Oksana, but it's a wonderful, it's, you know, I often would go to Rent Corporation when I live in LA and attend Yefron's talks. So he prepares that, checks what is, when his approach that with when you discretization, you increase, that it would be instead of log function, C log log, for Cox exponent, and one interesting like conclusion. What he would say, and why I like it, that his approach wouldn't give a better understanding of estimation of betas, but it would give simultaneous estimation of baseline with beta. And again, you know, he doesn't have even theorems, but he writes likelihood with nuisance parameters and explains that limiting process. Okay. Now the most difficult part. The most difficult part. We still have 35 minutes, I believe. The most difficult part. It's imagine you are portfolio manager. You have I don't know, let's say 150,000, 30 years fixed mortgages, loans. And you would ask me, okay, I want to know prepayment profile of the portfolio. I want to dig into some specific segments of the portfolio. And then you would tell, okay, I use Cox, I use, doesn't matter, but I use where my covariates, FICO score, everything else, it's a time of origination. It's true that you can, at time of origination, then you can use also time-dependent extensions. But the whole problem that if you have portfolio as of, let's say, March 5th of this year, and you are looking at prediction for the next that portfolio cash flows, you obtained already some information which is not in standard survival analysis. You have current FICA, you have current delinquency rates, you have even current state of the economy. Something you can use prediction as time-dependent variables. But think as a probabilistic model. You cannot predict people delinquencies. You cannot predict their FICA based on today FICA. You just, you need very weak probabilistic assumption on changes of those variables. Also, I want immediately to tell you biomarkers problem. They have so-called landmarks for biomarkers. So they conduct some study and they know that it would be a follow-up in 6 months. They would measure, let's say, something about blood, and it would be new information. So it's also, so the whole problem, it's dynamic covariate. You have to predict not from age for that particular, from 0. You need to have model at age, let's say if it's mortgage with 5 years history, it's at 5 years or whatever. Then you have to understand that, like, something what I didn't tell about that prepayment. Standard baseline is very simple. At first, people, they get a mortgage, they are not willing to move, they are not willing to refinance because it's additional cost. So for 6 months, it would be in accounting just linear function. Then they have some area where everything depends now on interest rate. It would be a line. And then you have something, because people with age, they're lazy, they're not good financial engineering, they don't look for that opportunity of prepay. So it would be like burnout. So it's such non-linear accounting model. And then they would put, as in Cox, they would move that thing according, let's say, to FICA or whatever, that baseline profile. Okay, so here I just, it was for regulators, I wanted loan dynamics that imagine people, they did, I mean, they miss their payments. It's called in delinquencies. They have, let's say, 30 years delinquency. Oh, we are not concerned, they forgot, then 60, then who knows. Then they can go into default. Or maybe they had delinquencies they wanted to prepay. It's a very difficult.
How to translate into Ukrainian delinquencies?
Delinquencies, like запаздывание in Russia, they didn't pay in time. How you, Professor?
Lag, часовой lag.
It's in length. Delinquencies. Shish, I needed to sorry, I was in a hurry. No. People, each month before March 15th, you have to deliver to bank, let's say, $2,500.
Yes.
And you didn't prepare, did it in time. After 1 month, bank asked, what happened? You can prepay. Or you could say, oh, forget, I would wait, what's gonna, or I would try to find money. It could be then 30 days delinquency, 30 days, not, як буде українською?
Задержка платежа, самое аккуратное, по-моему.
Затримка платежу.
Yes, in Russian it's задержка.
Ну и Russian, я не знаю, как in Ukrainian.
Затримка платежу.
Окей.
Затримка платежу. 30 days, 60 days. What is amazing in that behavioral, like here it's, I would give you just interesting what is how to describe with statistics. Generally, if you have good person with good FICA, you would say, "Oh, I don't care. It's something they miss, right?" So, if you have information about people with perfect FICA, with the credit score, and with FICA, which is kind of not good, let's say, you expect at first that maybe propensity to default finally to go into default would be smaller for a person with excellent FICA. No, it's all the way around with baseline. It would give increase of baseline. Why? Because often when people, they have perfect history and they stop paying even 30 days, it means that something happened. Either they are going through the divorce or they lost the job. So it's interesting behavioral model. Okay, so we expect one dynamics delinquencies, loan curing, their current. Як буде current? Then catch. З цього часу вони платять, як все, вони вилікували свій лон. Curing – it's вилікувати. And then after they вилікували, they still have record that they didn't pay. But eventually, their FICA improves. Just so you would understand that I'm not dealing just with some well-defined statistical model. There are many hooks where you need to put those behavioral assumptions. And we'll talk about that later. Okay. So now the most complex part, dynamic covariates. Static predictions, it's information at origination. Dynamic predictors, information as of now. I have current FICA because it's a good example that you cannot predict at all. For example, economic conditions, you can make projections, but who believes them about so-called prices, GDP, or other. But again, even for them, you can use current information. Then it's a very complex problem, even in classical good realm of stochastic differential equations. And I know that we talked about Diekman, and that he spent a lot of time trying to how you could put past dynamics into your stochastic differential equation. Besides prediction, it's kind of how you would extend, how you would, instead of Markov property recent, how you would, is it possible to create some reasonable model when you extend the whole history kind of, okay, sorry, I'm stuck. Somehow you would compress that information into something what you believe would be functional for that Markov property. Anyway, I wrote it. Almost the same, but performance history has a complex Markov presentation. Okay, let me be clear, like FICA. You want to know not only current FICA portfolio manager, but he would say, but how they behave, it's old law, how they behave 2 years ago. Maybe they have the changes in FICA, or they have delinquencies. I still think it would be useful information for me. Okay. What's okay? And time-dependent predictors for such setup. Remember that it's separate predictive models, time series models. It's by the way, you know, I have personal attachment to the name Kalman. Kalman, he was doing he was interested in econometrics, and his conclusion it was that it's not science, even from Frisch work. But it's a different story. Okay, now one approach how people who implement that two baseline, how they would think about this problem. Look, we have for 30 years mortgage, we have 360 points, right? Each month. You get that notification, they pay, you can obtain your information each month, 306. You can develop excellent Cox model with start zero. Then you would say, oh, I would develop another model based on my head. For months 3, let's say, then for months 6, I would have, if we have that period, let's say, not 360, but we would have 120 models. Their betas, their baselines, they would jump all over the place. We would lose interpretation. We can so how we can average over the time and create just one parsimonious model. Parsimonious model, here I want to say something important. At each point we have information about loan age, and then we go for that months forward. And it's a very important concept here, because our dynamics, remember, how it's going on from Euler, I can say, everybody would understand. People in actual, they stack all those loans from H0, they build triangle. It's called chain ladder. And so it's very important in terms of so-called H period cohort paradigm to understand that loan age today is loan H0. Loan age, when we going to predict something, it will be loan age plus time of prediction. Why it's important? I saw a lot of models when people, they perfectly predict based on the future information default, like it's some deep mistake. Anyway, just to give you that idea. Now let's go now to that presentation, and we are almost done. No, maybe I have to say one problem. One problem about that people, they realize that they can smooth that 360 models. They would smooth it in the following. They would think that baseline depends on what's going on time and loan a on time forward and loan age. So forget about our knowledge of probability. I would write it, it's very bad, but it's some function which depends on months forward and L loan age. So loan age at when we need to predict historic time, it would be loan age plus t. Now, oh, I wrote it. So here it's very difficult to think, and it's about, and if we have time, I would go through attachment in terms of conditional expectations, but it's natural to think that all those models, their changes, you can describe by additional decomposition of that baseline into usual usual months forward baseline of Cox, and then something what we smooth over that time of long ages. And here it could be confusion because even Scandinavian school, I'll show, they would do some confusion when they derive. I mean, for me, the main stuff that as practitioner I would say, okay, I would try to do two splines, and then I have my exponent or Yefron, whatever.
And something is wrong with brackets in this formula.
Professor Kukush, it's true. Something is with so beta. It's completely. You're right. Of course, beta it's multiplying each beta for each R1, R2, and R3. Here I wanted to say that R1 we include. Yeah.
Beta 1 times
Thanks a lot.
R1.
As a mathematician, you always, what I need to say. We have three covariates we have to say. And they have their own beta, constant, let's say constant beta. One beta, for one beta, is for R1, information at H0, when we gave this loan. Second, dynamic information, 5Ks of today. And we can allow time dependent, it's R3. And of course, Professor Kush is absolutely right. It's just linear form with different beta. Sorry.
Beta is three-dimensional vector, right?
Correct. Absolutely.
Your multiplication is inner product in Euclidean three-dimensional space.
Yeah, but yeah, I did it for regulator, so obviously it's. Here I don't know if I would talk it, but remember one thing, that when you build the stable, you can repeat one loan many times, because one loan you can use for starting from zero. The same loan you can, if you have history up to, let's say, 3 years, you can build this loan would be participating in your 36 models. And it's immediate question that what's going on. It could be bias, it could be correlation. It's statistically, you cannot multiply already known information. So it was the problem. But people, they would create such data sets and run their estimations. And it was crazy because, first of all, it would take at that time months to get results. Second, regulators, they would come and they would present to them their back test on 60 million loans, because each loan would be over there like 40, 50 times, and totally in the US at that time, I believe it was around 50 million loans. But what I'm trying to say is that it's serious statistical problems, serious. Okay, and they called it exploded data set, and immediately regulators, they would prohibit to use that technology while it would give a lot of information. I mentioned, so I call it horizon data set, and I would explain. And I just explained that people, they would run betas, they would get two, by the way, very reasonable two baselines, very informative. But So there is need for Monte Carlo, because at the end of the day, what is Monte Carlo? We have to estimate conditional expectations, and what we are doing is just trying to estimate baseline and betas and make sure that we can interpret more. So what my teacher he proposed in order to reduce, he proposed that, look, we have loan censoring, it could be up to what we know about its history, and we drop randomly for one loan, we just drop randomly a point and pick up its age, model from which he would participate, that loan, it would participate in our one model. Okay, so what is the whole beauty of it? What I like it a lot and why we've been doing it? Because you use information about one loan only once, right? Second, it doesn't look, it would introduce a lot of bias, but it's mathematically it's questionable. So, but second, why it's good, because you can use bootstrapping techniques. You can repeat your randomization. You can prepare all that alchemy in terms of, I don't know, asymptotic statistics, but it's somehow supported by from all theory. Oh, I said repeat randomization with, I don't know, with different seeds. Anyway, bootstrap, you can check confidence intervals. It was 2012. Oh, very important part. The way how we would get that information in finance, it wouldn't change initial baseline a lot. It just influence, it would decay. Because if you know for information and train your model for loan age 36 with some FICA information, you that information model would pick up, it wouldn't be useful. It's like influence function. It would decay. So there is that time scale in which would be important if you would like to listen more about Kalman filter. I would talk about it. Now, okay, again, it was 14 years ago, and remember that I started thinking about statistics only when I was 38. So it's kind of it was 12. Description of the FICA and delinquencies as stochastic process. Something what I wrote the following. They're not probably stochastic processes because we don't have stochastic. It requires some stochastic stability. But what I'm trying to say that for a short time, can we find something like for 3 months or whatever? What are our assumptions for our Monte Carlo besides behavior? And it's a difficult problem. Then besides FICA and delinquencies, think with biomarkers, and I would talk time. I'm sorry. We have 10 minutes, so we can go over also that stuff, what I think Professor Kukul's research and and then my crazy ideas just for the next time. You can consider for biomarkers, it's better. You can have actually with stochastic stability where you can use Brownian motion, Uhlenbeck or OU process. It's Arnstein-Uhlenbeck process. You
and
can
fractional
consider
Brownian motion.
Yes, but you can use Brownian motion with particle skill. You can, and that part I just send me. I'll send because you see I started going through it only after the first seminar. I revived, and it has been done a lot by Scandinavian school and others. I recently sent to Professor Kukush, person in New York who I very respect as quant, Andrew Lisnevsky, very good mathematician. He worked for some hedge fund, and he is mortgage expert as me. But what I saw, I don't think it's the right way of doing it. But anyway, okay. So now, at that time when I was making that presentation, I believe in 2013, it was dynamic prediction and clinical survival analysis. And we'll talk a little bit about that. And Ephron, it was main papers for me at that time. Okay, so we're switching now. I escape. And we're going to my attachment. How I can, sorry. I Control L. Okay. Okay, now it's just, I call it why asymptotic foundation remained elusive. Let me go at first, because we have like 10 minutes we have, right? Or,
Yes.
okay. So what I want to say, at first, again, I used to be a mathematician, and for me as practitioner, the most important about statistics, and it was strange person, I don't know if you heard about him, John Tukey. He invented some strange thing, robust statistics. He was mathematician topologist, but he became statistician, which have a lot of stuff about assumptions. He was ignorant about mathematics. Even there is a wonderful International Congress of Mathematicians, his results, and he would talk about it. So I want to, but he was the first to conduct, I believe, that very useful Monte Carlo studies. And here something for me very important. He has a wonderful presentation in memory of John von Neumann. And he would talk about his configural polysampling, what they did with his students. And here I would go later why I think for Monte Carlo it's important to understand what statisticians do it. But he was kind of I believe even students, Huber, Hampel, they would do with exact Gaussian some results, which later they would convert into asymptotic robustness theory. But his theory that we have enormously complex problem. We have to start from toy models. They are not useful. Then have leading cases. It's so-called anchor specifications. And then we can finally have something what we would call the model. So it's two fundamentally different philosophies he presented. Asymptotic theory versus finite sample, all those islands, anchor, special leading cases. And his argument here quickly, it's unavoidable, toy anchor model. Okay, let's go, here. First of all, before a discussion asymptotics, let's consider biostatistics and finance. For biomarkers, number of subjects a week, sparse. Oh, sorry, something was. Can you hear me? Can you hear me?
Yes.
Hello. Oh, okay,
Yes.
sorry, unstable. Anyway, what I'm trying to say is that what we discussed during Pani Oksana presentation. Finance has large N. It's good for your results, but it has such crazy dynamics which can describe only by some filtration. Biomarkers, they have small n and weak time dependence. Now let's go to what could, I think, could be done with that Scandinavian stuff with. Okay, so that part. It's I was trying to present why it's an enormously complex problem. It's you know it's better than me. Now, the whole problem with Scandinavian school, they use something which is called Cites and Anderson approximation, and I haven't seen good. I mean, Alan, they're very smart people. I haven't seen. They claim that it's. I haven't seen how it to do, especially because they would propose then. So remember, I did something completely crazy presenting you, but they present so-called hazard generalization of baseline as conditional probability, I think, T of S. And then for they use for that function, they use splines because they somehow for some toy models, they're not toy important, they're able to do that decomposition. Yeah. So I'll send then they have some results. Obviously, we didn't touch that delinquencies, they're discrete, so they use it in conjunction with Markov state. So what I'm trying to say is that going through complex interpretation of using martingales and Markov and moving ahead with baseline and so-called partial likelihood, we are going in very difficult area. But what I wanted to say, just myself, as practitioner, I feel that Monte Carlo studies feel unsupported. Okay, and we need let's say today I presented that, and I just gave indication how that theory could go with some results of Scandinavian school to combine regularization, let's say, of baseline. But I want to say that if audience is interested, I can make a presentation about Kalman filter, like for students, because it's very important, something very important to me. And I want to say that in finance, what I saw related to finance, people, they would do Monte Carlo and justify them with particle Kalman particle filter. But I have a different thing. So what I'm trying to say is that in sense like Professor Kubush, when he was explaining that about Monte Carlo studies, that in reality, I forgot that about histograms last time. Professor Kubush, do you remember it was something you comment? Anyway, I just want to finish because, sorry, you are probably tired of me. And yeah.
We can give you 10 minutes if you want.
I just want your maybe question, your questions, because in reality, I think that it's a very difficult problem related to filter Kalman. And I wanted to go through with you about Gauss-Markov exact filter Kalman, and then go of variation of it when you don't have Markov dependency. By the way, it's something about students doing that stuff. Kind of, I realize that uh, if you consider R1 with multiplication of noise to previous, you have very good example when second order stationary process. Let's do what Bryman, what I learned from him, that if you have secondary order, second order stationary process, so stationarity by mean and by covariance, and if that covariance is like not Gaussian, it's covariance exponent minus alpha module t. It's not trivial to build example when it's non-Markov. Non-Gaussian, it's easy to talk, but when it's non-Markov, it's difficult to build. It was for me, and it's the simplest example how to do it, and it's actually what is good if we discuss, if you like it, about filter Kalman and how it's related to then this problem with my program, because it's also something what we're supposed to talk today about filter Kalman with small noise. It's good noise, but I have a different view, more like Boголюбов. Put epsilon equals 1 and use it in your research. Okay, I'm done. Thanks a lot. I don't know if you are tired, and it was, I don't know. I just want to thank all of you.
Thank you for your talk, interesting talk. And any questions?
Yeah.
And I understood you want to give us another talk, Igor Fomenko.
One second, I need.
Okay, then Igor Mandel, you can ask your question.
Well, okay, thank you. Thank you very much for your presentation. Let me ask one very general question, because it looks like that you missed some pieces of the general explanation, but let me then ask very generic question. In your calculations, it looks like you did some real simulations, because it's
right. Not right. Simulation.
And my question is, how does it fit the data? Because usually when I worked with dynamic data like that, financial data like that, it looks like
dynamic panel
have some
data,
pieces of data, like piece of time, and then forecasted for the future, then again in moving style, right? And then you compare the results. How your results look like? Like, could you show some?
You know, it works quite well. The whole why it works quite well. The main of course thing it's to build so-called prepayment speeds. It's what I can say, and it has a lot of good interpretation. Again, here you cannot have. It works well. Why? Out of sample, it works quite well. Out of sample and really with honest prediction. So,
So you mean it satisfies the financial institution you work for.
Yeah, yes. Yeah,
Okay.
and that's why they wanted to use it, but you know,
But if you calculate determination like arc squares, the simple statistics between your
oh no, it's
predicted values and actual values, I mean,
yeah.
in backtracking, how much would it be?
Oh, okay. Here it's maybe different topic. What kind of metrics we use to say that model is good? Because remember that for survival models, when you do just you front, you know, if you get, let's say, R squared 25%, it's perfect. Behavioral models often, you know, if you have good R squared, it's just indication of that something is wrong with model. It's very weak signal, but it's possible.
It is indication of that if it works for the same piece of data. But if you are going ahead, if you forecast, then it's not. Then it tells you forecast very well.
Huh?
If you make prediction mode in your backtracking system, then it doesn't tell you about overspecification of the model.
Yeah, you're talking not about model of goodness of fit, because it's also a big topic. You're talking about forecasted.
Yeah, I'm talking about level of success of the prediction, not of course.
Yes, but it's forward probabilities, and there are special technique of calibration, and it shows that it works well. You cannot use obviously R squared, but you first of all you can monitor for the call that 30 years prediction with some confidence intervals. You can do it. It's not actually confidence; it's prediction. But remember that it's survival model and prediction of baseline. I need to prepare, because I need to explain all those metrics, because people they use bootstrapping to understand quality of the prediction.
Okay.
I mean, the best is to predict going back 3 years and look at prediction as you were there, your difference of your forecast with actuals.
Okay,
but,
thank you.
But yeah, but again, remember that forward expectations, it's what you think what market would be.
Right.
So imagine that when you do what you ask about, what is the proper word? Back testing, proper back testing. It's a very important concept. Proper back testing, often you don't know what, I mean, how you would catch what were market expectations at that time and so on. They could be, that part actually, it's very interesting. I can present that topic, you know, for behavioral models. What does it mean, good prediction model? It's a big topic. You know, it's regulators, they don't know even what to do with it.
Okay, thank you.
Yeah, okay, thanks.
Any other questions? Or then we thank once again our speaker, and it is not clear who will give a talk next time, but I will inform you. And
but
welcome.
How often all those seminars
each
go?
Week.
Each week?
Each week on Wednesday.
Wow. Each week. Very strong commitment.
Yes.
Okay. Okay, let me know. Thank you very much.
Yeah. So. Yeah, thanks. So if again, it depends. I could prepare how in really in finance, but obviously maybe you're tired of me. Okay.
No, we are not tired. If you can explain us how you use Kalman filtering in your work, it would be interesting.
How I use it's one story, and another story how I can think we can use it for building baseline, but it's a big problem.
Yes.
I need to write because right now it was maybe interesting, but still more like hand waving and the reference to that Scandinavian school.
Yes, and next time we would like to have more formulas to,
Yeah, of
to
course,
discuss.
of course, because but what Professor Mandel he asked, I can prepare a special topic because I have few Bibles in science, and one it's regression modeling strategies by Frank Harrell. It's and just recently I asked him about when you have low R squared, his opinion, and he wrote, "Oh, if they have," and now I'm examining some guys they have R squared 0.96, and it's not a model; it's just some fudging. I'm sorry to say, and
Well,
it's a different story.
It's not necessarily R square. In my mind, it's very simple. Like if there is a flow of different events and the actual one, and then predicted one, and they are placed against each other, then you can use any statistics. You can use, let's say, absolute deviation of one against anything works, which normal statistics, which shows how good you predicted it. I don't think.
Yeah, that part you're asking about kind of classic. Okay, so for forecasting, and I don't like it at all. People they use nowadays may, I don't know, mean something, and somebody wrote a wonderful paper from England, and I think that they're right. It's just mean apes, як дратовані мавпи. I'll send, by the way, about MAPE, I'll send, it's interesting. I'll send it right now. Very interesting. But look, MAPE for those models, I don't think we can even use. It's a completely, it's not standard forecast. It's the same as like how you would check for, I don't know if you're familiar with filter Kalman, how you can check performance on filter Kalman. You cannot use.
If you do it on certain historic period and then apply it to the future, then you can.
Yeah, but the time series is completely crazy. If you consider those, it's. I mean.
Okay, but it's a long topic. Okay.
It's a long story. Yeah. So sorry, I can without. Yeah.
Yeah, maybe it's not relevant even question. Whatever.
No. It's a question about model performance. It's extremely relevant. It's just we need to think what are our outputs and how we prove it.
Okay.
Igor Fomenko, and people ask, what do you mean but in this slide?
So I'm sorry, Dr. Kukur, Dr. Fomenko, I have to leave. Thank you. Thank you very much.
I don't know. Maybe what I'm.
You wrote but.
Yeah, probably it was just cut yesterday night. This example it's beautiful when you can build AR1 with epsilon t as multiple of nt whatever minus 1, and it would be Gaussian autocorrelation, and it would be non-Gaussian, and it would be non-marker, obviously.
Yes, clear.
Why? And it can give the whole story. Multiplication, is it relevant to winner? It's not. He would do like a Nova presentation. How it's called? It's students. They can start. Yeah, it's like a Nova, but students can start. It's. I think that I've never seen in R1 autoregressive that people they would do such research with nonlinearity, because kind of when you look at that, it's usually we think, what is nonlinearity in stochastic processes? Oh, it's something like x squared. No, here you have kind of linear dependence, but noise remember about itself.
Yes.
And if you calculate, it would generate. So I look, Sasha. I haven't seen it in any. I mean, I believe it's a good example how to build it, because people say, because you know why. If you hear, you would consider Levy or some, I mean, heavy tail processes. I'm not sure, that maybe I'm wrong, but often you would get still Markovian property. You understand? It's something I need to check. It's of course, but what I'm trying to say is that it's not here heavy tail. It's something what immediately would break Markovian property. And I just, I started, we discussed something previously, and I started thinking about it. I started checking that Breiman's book, and it's different from his book. It's lectures for applied probabilists, for engineers. And I realized that something what, anyway, maybe I'm wrong. Thank you, everybody. Thanks for your patience. My style, maybe somebody doesn't like it, but I'm, look, today is second time in my life when I present in Kyiv. First time it was June 25th, моє день народження, and it was 1986. Це був Чорнобиль. Це була моя дипломна в Феофанії в Інституті кібернетики. And it's kind of what I can say. Thank you for this opportunity. Thanks a lot.
Okay. And I'm waiting for your proposal for the next talk in 1 week, maybe.
Oh, you're willing to continue? Okay.
Yes, we can continue.
At first I need to check with you, and it would be about that stuff. We will go about Kalman field. But remember, I want to find time to. At first I would write on paper, and then I would present. So again, don't expect theorems, but some mathematical, almost well-formulated problems. Okay?
Okay. So goodbye. Then we
thanks a lot. Thank you.
Session.
Goodbye.
Thank you, Professor Mayberg. Thank you. I appreciate it.
Goodbye.